Hopefully everybody had a good break, and we're going to get right to it. We have about 2 weeks left, and then about 1 week of teaching, and then hopefully 1 week of projects. So we're going to try to get to this stuff pretty quickly, get through it, and kind of close off our unit here. So what I have here is kind of 2 examples of elastic and inelastic. So we ended last year with inelastic collisions. And what stuck out about it was that it was stuck together. So either they were together as one before they came apart, or they're 2 separate items and they came together. So that's what I mean by stuck together. In this case, you have 2 runners running at each other, one this way, one this way. After they collide, they're stuck together. So you have initial momentum is equal to final momentum, and then you kind of just plug everything in. Mass of one person, velocity of one person, plus mass of the second person, velocity of the second person is equal to mass of the first person, velocity of first person, plus mass of the second person, velocity of second person. These are all initial, and these are all final. What makes this nice is that when they're stuck together, their velocities are the same. So you can kind of rewrite this a little bit differently. So mv plus mv, mv equals m plus mv. Like I said, they're stuck together, so their velocity is going to be the same. And you just plug everything in. You have 95 and 3.75. I'm not going to do the calculation of this. I just want to show you kind of the setup. So I'm going to set it up and then just stop. 4.10 equals 111 plus 95 velocity. Now, here one of these has to be negative because they're running towards each other. I didn't tell you which one was which, so it doesn't really matter. You can pick the 95 kilogram runner or the 111 gram. I read from left to right, so usually since my picture's that way, I'm just make this one negative. Okay, but there it is. Here's my setup. I have one unknown, so we could just plug it in, do some calculator stuff, and then we should get our answer. These are pretty easy, or the opposite, where you have, let's say, something that's shooting out a barrel. You have one velocity in the beginning, most likely a 0, and then you can figure out each individual velocities at that. So that's what we did last year before we kind of took our break. Now I kind of want to do something called elastic collisions. And we kind of talked briefly about it. Ooh, I'll kind of fix it that way. We said that they bounce apart. And I kind of also said that both momentum is conserved and also kinetic energy is conserved. So that's nice. Why would we need it? And you'll see really quickly. I'm going to change the color so that it doesn't get too confusing here. You have the following. So kind of like before, mass velocity plus mass velocity equals mass velocity plus mass velocity, because pi is equal to pf. Initial momentum is equal to final momentum. You could label all these if you want, kind of like we did here, but I kind of could keep track of it in my head. But if we want, we go 1 1 2 2 1 1 2 2. So we kind of labeled it that way. Usually I don't. I usually just plug it in. So for this one, I have 3 times 10 plus 2 times negative 10 equals 3 times v 1f plus 2v 2f. Now you will see really quickly that here you have 2 variables, 1 equation. So it's not as simple as this one. So you're going to have to do a little bit of work. In this case, you're going to have to do kinetic energy. I like to do it a little bit differently. Technically, kinetic energy is 1/2 mv squared equals 1/2 mv squared, final initial. But you'll notice right here really quickly, you could get rid of some stuff. You can multiply both sides by 2, so you kind of save a step. So you could just have mass times velocity squared equals mass times velocity squared. So that's what I'm going to do. I'm going to set up my equation just like that. So it looks just like this one, but instead of having it not squared, it's squared. So I'm going to kind of do it right here to give myself room. m1v1 squared plus m2v2 squared equals m1v1 squared plus m2v2 squared. These are initial. These are final. Do the same thing, plug it in. 3 times, and you can kind of just look at what you had before. 10 squared plus 2 times negative 10 squared equals 3 times VIF squared, sorry, 1 plus 2v2f squared. So you have this. Now you have two equations, two variables. I would substitute one into the other. And you can tell it's just not as fun. So this one's 300 plus 500. Oops, I did it in my head. Plus 200. Square negative becomes that. 3v. I'm just going to call it v1. I know it's going to be f just to save myself one. Might as well leave it. Squared plus 2v2f squared. Solve for it. So you have 500. And you have to make a choice. Whether it's this one or this one. Let's solve for, it doesn't really matter. Let's solve for v2f, so minus 3v1f squared divided by 2 equals v2f squared. Take square root. Plug that back into here. So you have 30 minus 20. And I'm going to substitute v2f. So I have equals 3 times v1f plus 2 times this sucker, the square root of 500 minus 3 VIF squared over 2. Okay, so you can tell really quickly these get really ugly. And for me, I'm going to give you nice numbers almost always. And if you get really nasty numbers, that's when you kind of just pause and go, okay, did I do a simple mistake that I did wrong? But now it's pretty much just algebra. Oh, now it's pretty much just algebra. So you just kind of need to figure out algebraically how to solve for VIF. They're the same variables, one variable, one unknown, sorry, one equation. So you can figure that out. You just have to do the math. I'm going to kind of pause it so I have more room to do this math. This is way not enough. So give me a second. Alright, so I erased my left side, and now comes the fun, not so fun part. I kind of enjoy doing this, even though I get frustrated when I make a stupid mistake. I'm going to rewrite this entity right here. So 30 minus 20 equals 3. Now, you have a choice. You could keep the substitution that you have here, V initial, sorry, I always keep messing up, V1, ball 1, final velocity. Since we kind of know what it is, you could just drop that, but just you have to keep in mind this is what we're solving, the final velocity of ball 1, and then kind of come back to it. We could do that. I'm going to do that just to make this side much more simple looking. So I'm going to just substitute it with V plus 2 times the square root of 500 minus 3V divided by 2. So here's my equation. I'm going to try to solve for it. It's kind of ugly. It's going to take a little bit of time, but it's not too difficult. So I'm going to move everything that's not in the radical to the left side. So you have 10. So you have 10 minus 3v divided by 2. And then you're left with that. We're going to square both sides. So I'm going to simplify this entity into 5 just to make my life a little bit easier. So 5 minus 3 halves v times 5 minus 3 half v equals 500 minus 3v squared over 2. Believe I did my math correct. Looks good. 5 times 5 is 25. 5 times 3 halves is 15 over 2v minus 3 halves times 5, which is also 15 halves over v. And you have here 3 halves times 3 half v, so you're left with 9 over 4v squared equals this, which is 500 minus 3v squared over 2. I want to get rid of the fractions, so I'm going to multiply everything by 4. So 4 times that equals 100. 4 times that is 30v, I believe, right? This one is also 30v. 4 times that equals 9v squared. And then 4 times this will give me 1,000 minus 6v squared. Okay, so it looks nicer already. Notice that most of it's nice big numbers. I put everything on the left side. So I'm going to move 6v over. So I'm going to do plus 6v. So that'll be 15v squared minus 60v. And then I'm going to move this over, minus 900 equals 0. Let me make sure I did my math correct. Plus 15, that looks good, minus 60v. Yep, I believe we could divide everything by 15. We can. So it's v squared minus 4v minus 60 equals 0. And now we just want to find the values of v. So we could do that. 6 times 10 gives me 60. The difference is also 4. Yep. Okay. Negative 4, so the negative's going to be on the bigger one. Let me make sure it's right. V squared, negative 10, positive 6, 4. Perfect. So the answer for V1F, keep doing that, VI, is negative 6 or 10. One of the answers will always be, and that's the weirdest thing, one of the answers will always be the initial. So the answer is going to be this one. Okay. Plug this all the way back into any of these equations to find the velocity of the second ball final. So we could do this equation or we could do this equation, doesn't really matter. Either way will give you the right answer, and that's it. So it's actually pretty straightforward. The math is ugly. The good news is the problems that hopefully if I make it right will be nice whole numbers. But if they're nasty numbers, then you're going to have to use the quadratic equation right here. For us, I'm going to try to keep it making sure that all our homework is going to be nice even numbers, so we could practice that. But other than that, if you get something that you can't square in your head or through work, then you just do a quadratic equation.